Hi, Marco. You're representing STMicroelectronics with a keynote on sustainable on-life era. Can you just explain what that is?
Yeah, in my speech, I'm talking about technology innovation and sustainability. And ST has this as a mission, so of developing technologies and sustainable technology. We are committed to carbon neutrality by 2027, for example. So in my speech, I'm trying to answer the question on how to combine the need, the wish of more comfortable life augmented by technology with the need to preserve the planet. Yeah. Okay? And to do that, basically, I'm really talking about how semiconductor is at the core of electrification and sensorization, bringing the efficiency to the node. So we are able to bring efficiency everywhere. Thanks to the scalability of semiconductor, that enables higher voltage management in an efficient way or more processing power locally for motor control, power conversion, but also in the sensor for sensorization of nodes and collection of data.
Oh, interesting. What's the role of MEMS sensors in enabling that vision?
Cool. MEMS sensors play a big role here. First of all, by themselves, they can enable human-centered, sustainable applications. What I mean, applications that are enhancing our life, but also in a sustainable way. Why? For example, consider presence detection. You have presence detection in building that can define how to generate heating or lighting in an efficient way, or on motion-activated devices that are off and you wake up only when it's needed. So these are examples of sensors. Making smart sensor brings computation into the sensor, into the edge, into the node, and this offloads the entire chain, microcontroller, connectivity, cloud processing. So we go farther down the road of sustainability, bringing the processing into the node and into the sensor.
Oh, wow. You mentioned smart sensors. Can you elaborate a little bit more on that? I mean, you do have one of these products as a finalist, I think, in the AI category, correct?
Correct. We have an accelerometer, smart accelerometer with machine learning core embedded as a finalist in the AI category. So eager to know the result. But what are we doing? As ST, we developed two technologies, a machine learning core engine that is capable to be, it can be trained, it can execute a decision tree and act based on specific events that happens locally for which it has been trained. Or we develop a more advanced, what we call ISPU, Intelligent Sensor Processing Unit, embedded still in the sensors. That is a more specialized DSP, more advanced, able to run complex AI operations. Those things enable what I was saying before, enable the smart sensing capability, so processing local information like monitoring continuously an engine and providing data to the cloud, not continuously, but only when there is a particular vibration that is detected, so switching on the system.
So you talked about motion sensors and how they contribute to energy savings. What other sensing technology does ST see as addressing especially valuably to meeting the needs of sustainability?
We are introducing here and presenting a new technology, a unique technology. It's called TMOS. TMOS is a passive infrared sensor that can detect presence and motion at very low power, microwatt, few microwatt to detect presence in a room or power or motion. So with this TMOS, we really can enable use cases on power saving, energy saving. It is very impressive.
What kind of power savings might these sustainable solutions provide us? Is this significant enough to make your goal 2027? Well, that's internally.
We measure sustainability by carbon emission at the end in a certain way. We have different use cases working with our supplier, customers, and partners. One example is with the TMOS I mentioned, we can save 260 kilotons of CO2 per year if we embed a sensor in all the offices in the world, and we save 10%, 1 hour on 10% of the lighting we can switch off. That is really very important. Yeah.
Hey, thank you, Marco. I appreciate your time.
My pleasure. Thank you.